The sun heats the Earth, making it habitable for humans and animals. But that's not all it does. It affects a much larger area of space. The space influenced by the sun, known as the heliosphere, is 100 times larger than the distance from the sun to the Earth. The sun is a star that constantly emits a steady stream of high-energy ionized gas called the solar wind. In addition to the constant solar wind, the sun occasionally releases plasma bursts called coronal mass ejections, which can contribute to auroras and flares, which are bursts of light and energy. Plasma from the sun, along with the sun's magnetic field, expands into space. Together, they form the heliosphere in the surrounding local interstellar environment, which is filled with plasma, neutral particles, and dust. We want to understand the heliosphere and how it interacts with the interstellar environment. All the known 8 planets in our solar system, the asteroid belt between Mars and Jupiter, and the Kuiper belt, which includes the dwarf planet Pluto, are inside the heliosphere. The heliosphere is so large that objects in the Kuiper belt are closer to the Sun than they are to the nearest boundary of the heliosphere. When distant stars explode, they release large amounts of radiation into interstellar space in the form of high-energy particles known as cosmic rays. These cosmic rays can be dangerous to living organisms and can damage electronic devices and spacecraft. The Earth's atmosphere protects life on the planet from the effects of cosmic radiation, but even before that, the heliosphere itself acts as a cosmic shield against most of the interstellar radiation. In addition to cosmic radiation, neutral particles and dust continuously flow from the local interstellar environment into the heliosphere. These particles can affect the area around Earth and even change how the solar wind reaches Earth. Supernovas and the interstellar environment may have also influenced the origins of life and the evolution of humans on Earth. Some researchers speculate that millions of years ago, the heliosphere came into contact with a cold, dense particle cloud in the interstellar environment, causing the heliosphere to shrink and exposing Earth to the local interstellar environment. However, scientists don't really know the shape of the heliosphere. Models range from spherical to comet-like to crescent-shaped. These estimates vary in size, from hundreds to thousands of times the distance from the Sun to the Earth. Scientists have identified the direction the Sun is moving as the nose direction, and the opposite direction as the tail direction. The nose direction should have the shortest distance to the heliopause, the boundary between the heliosphere and the local interstellar environment. No probe has taken a good look at the heliosphere from the outside or properly sampled the local interstellar environment. Doing so could provide scientists with more information about the shape of the heliosphere and its interaction with the local interstellar environment beyond the heliosphere.